Welcome friends. In this tutorial video I will demonstrate the performance of my newly created software Analytiqus. So in this video I will show you I will run an end-to-end machine learning project on Analytiqus, and I will demonstrate how easy to make an effective machine learning model using this software. So you can do many tasks on this Analytiqus software. Let us start one by one what you can do. You can do data visualization, you can do feature engineering, you can create machine learning model, you can do scenario analysis, or you can do optimization task like you can create optimization models to get the optimum value of the parameters. So in supply chain these models are highly useful, or in business purposes you need to find the optimum parameters for to maximize or minimize your objective function. So in this tutorial we will build a machine learning model that uh, uh, and for the classification purpose, and I will demonstrate how we can run an end-to-end machine learning project. That means from data editing part to building and training an machine learning model. So let us start our video. So now let us move to data editing and feature transformation part. So in this part we will discuss various options available on Analytiqus that you can use to transform your data and get your data ready for machine learning purpose. So there are various options are available, like date time, like you can do handle missing values by using some data imputation strategies. You can remove the outlier using certain statistical methods and histograms. You can do the data table operations, like you can join the two data tables and other database operations you can do here. You have feature transformation part, so here you can transform your feature. Then you have dimensionality reduction part, so in this you can use principal component analysis to reduce the dimension of your dataset, or and also you can remove the multi-collinearity from your dataset. So if multi-collinearity is present in your dataset, if two variables are highly correlated to another, you can remove those unnecessary features from your dataset. So and in the feature selection part, you can apply various algorithm to know the feature importance of your feature, and those feature which are less important or which have no importance to your model, you can remove those features because those are unnecessary. So in this part you can select the features. So let us start the doing the basic thing. So we will upload the raw data. So let us load the raw data, and uh, and we will transform this raw data. So you can see that in this raw data a target churn is there. So this is our target, this we want to predict. So here in this column no churn or churn is given. So based on the other columns, these are the features, so you want to predict this. So there are only two categories, churn or no churn. So you want to predict the churn of the customer. So let us check whether is there any missing values are present or not. So here you can see that there are two columns which have missing values. So the complaint column has 7 missing values, whereas condition of current handset column has 444 missing values. So either you can use data imputation strategies to replace this value with some other values, or you can drop this column. So here I recommend you, because this are very less numbers, so you can drop the entire row. Only 7 rows is having missing values, so you can drop. But here 444 you can apply certain strategies to replace the column. So let us do this column. So here since we had 444 values, so we can apply median or we can do forward fill, we can replace with constant values, or we can drop also, we can interpolate also. So if suppose we have date time data available, then we can do interpolation. So here we will replace the missing value with median imputation strategies. So let us execute these strategies. So now it has been successfully implemented, and then you can check it. So here you can see that there is no missing values now. Now let us handle this missing values. So let us do let us replace let us drop this rows. So drop this rows. So now you can see that there is no missing values now you want to replace, or now you want to transform your data set for machine learning purpose. So let us go to feature transformation. So in this part you have many options available, like binning. So suppose you have a continuous column and you want to bin those columns into certain categories. For example, suppose you have an age column and you want that to create certain categories. So you can do this using binning. So suppose you want to categorize your continuous age column into, say, children, youngster, elder, and in such categories you can create using binning. You have polynomial transformation, so you can apply polynomial transformation to create a higher degree column. For example, you can create more features. So for example, in your SVM say classification, you want to create new features. So there are options available like radial basis function, so you can create more features, but you can do here also using polynomial transformation. Then you can do log transformation. So suppose you have unstationary data set, you want to make it stationary, then you can apply log transformation. For example, in case of stock price prediction, you have trending data set or non-stationary data set, so you want to make it stationary, you can do apply log transformation. Or there are many other purposes for that you apply the log transformation. For example, suppose you want your data set has a very high variability, you want to reduce it, so you can apply log transformation. Then you know the label encoding. So suppose you have categorical column and you want to encode it, so you can use it with label encoding or one hotkey encoding. And scaling, which is a very basic operation that you apply for machine learning purpose. So you want to scale your data first, because there are some data value imbalance. Here you have a very high value, whereas this column has a very lower values. So you can do this. Also, in case of classification, you can do your data could be imbalanced, so you can apply that feature is also available. Now let us transform our feature. Let us do label encoding first. So we have the categorical column, so here we will do the label encoding for target churn, because only 2 categories are there. So let us do. So it has been done. Now you can check. So now it has been converted into 1 and 0. Now for other, since here you have more than 2 categories, so you do one hotkey encoding. You can do label encoding also, but better to go with one hotkey encoding. So let us apply this. So transformation is successful. You can check. So now your data set has been transformed. Now only one column is left, so apply one hotkey encoding on this column also. So apply it. Now it has also been converted. Now we want to scale this data set. So let us select the column that you want to scale. So let us select all the columns, all the features to scale. Let us apply min max scaler. and transform it. So now it has been transformed, you can check. So it has now been transformed, so all the data set has been scaled up. Let us save this. So save this to, say it is customer process data, say customer. So you can give any name and save this data set. So now we will use this data set for machine learning. Now let's start the machine learning part. We have already processed the data set. We will load that processed data set and split the data set and build trained our machine learning model. So let us start. So let us load the processed data. This is our data set that we have recently processed. So load this data set, upload this data set. Now let us see few rows. So here we have the data set that we had transformed for machine learning purpose. Let us select the features. So select all the features. So once you have selected all the features, you need to select the target column. Let us adjust the split ratio. So I am using 20-80 ratios, means for testing data set 20% data set will be reserved for testing purpose and rest will be used for training purpose. So let us split the data set. Now our data set has been split. Now we will build a classification model. So let us start with decision tree classification. So let's select the parameters here. You can give the options here. Let us execute the decision tree. So now we have built the decision tree model. As you can see that we have achieved 74% accuracy on testing data set. So let us try another model, random forest model, and see whether we get the higher accuracy or not on the training data set. So let us take the 30 columns, 30 maximum depth. Let us run the model. So yes, the model has improved. We have achieved 81% on testing data set. So in this way you can try many models. You can also try SVM models. Let us take RBF, and here you can, okay, let's see. So here accuracy reduced. So you can try different models and with different parameters and see which one is the best, which one is giving the best result. So here I think random forest is giving the best result. So this is how we can run the machine learning project on Analytiqus. So as you can see that how easy to build a machine learning model on this software Analytiqus. This software is particularly designed for those who don't want to do unnecessary coding and who want to remove the waste from the machine learning process. So you can remove unnecessary uh, coding and you can reduce the time of your project. You can build more focus, you can focus more on your data set and on your model parameter rather than focusing on writing the codes. So you can save the time as well as you can increase the efficiency. You can test number of models here and select the best model that is more suitable for your data set. You can try hit and you can trial, you can do hit and try on various model parameters also and see which one is giving the better result. Since hyperparameter tuning takes lot of time, so you can do hit and trial here because here you need not to code again and again. So you can just change the parameter and test the result, which parameter is giving the better result. So this is how you can build a machine learning model on my software Analytiqus. So particularly those who don't want to do coding, who don't have access to certain programming language, who doesn't who although they know the data set, they have the domain expertise, but they are not skillful for programming and coding, so they can make machine learning model here with ease. So let us end this video here. In other video we will talk about various other transformation like principal component transformation, or like removal of multicollinearity, feature importance, feature engineering, feature transformation, and various other transformation that we want to do for machine learning. So thank you very much for watching this video. Have a nice day.